Okay, let's dive into this. Welcome to today's Explainer, where we're going to strip away the science fiction, cut through all that hype, and uncover the real truth behind artificial intelligence. We're mapping out the whole evolution of AI here, from its early days of super rigid logic, through those devastating periods of lost funding, all the way to its incredible transformation into the active, smart agents that we use today. By the end of this Explainer, the way you look at the technology in your everyday life, it's going to completely change.
But to really understand AI, the very first thing we need to do is, well, forget the movies. Seriously, just erase that idea of a conscious, brooding super genius sitting in some dark mainframe room plotting to take over the world. Current AI, it has absolutely no feelings. Zero. No soul, and it certainly doesn't have personal opinions. At its core, AI is essentially just a highly sophisticated statistical calculator. It doesn't actually know things the way you and I possess knowledge. Instead, it relies on massive, and I mean massive scales of math and data to predict the most likely answer based on millions of past examples. So yeah, it might look like pure magic when it answers your complex questions perfectly, but honestly, it's literally just math and data operating at lightning speed.
And this brilliantly illustrates the big shift. For decades, traditional software operated on really rigid if-then rules. Think of it like baking a cake using a very strict recipe. If the user clicks A, then do B. The computer couldn't do a single thing the programmer hadn't explicitly written down. But machine learning, that flipped the script entirely. Instead of handing the computer a strict recipe, we hand it, say, thousands of pictures of cakes, a massive list of ingredients, and we just let it find the patterns on its own. It learns from all that data to make its own flexible decisions. This huge shift, from rigid rules to flexible pattern recognition, is the absolute beating heart of modern AI.
Section 1. The 1950s. The imitation game. Let's rewind the clock and see where this all started, going back to an era of massive mainframe computers and some truly ambitious ideas.
It all started with one simple, yet totally earth-shattering question posed by the brilliant British mathematician Alan Turing. Can a machine think? Now, up until this point, people were getting super bogged down in these deep philosophical debates, asking if a machine could have a soul or a true inner consciousness. Turing realized that was a trap. He argued, hey, we don't even know if other humans have a conscious mind, we just assume they do based on how they behave and communicate with us. So he suggested we shift the entire focus away from all that internal philosophy and look purely at external, measurable behavior.
To actually measure this, Turing created what he called the imitation game, which we now famously know as the Turing test. The setup is remarkably simple. A human judge sits at a terminal and types messages back and forth with two hidden entities. One is a real person, and the other is a computer. If the judge cannot reliably tell which one is the machine based solely on that conversation, well, Turing argued the machine has successfully demonstrated intelligent behavior. It was a brilliant foundational framework for the whole field, and impressively, it was conceptualized years before scientist John McCarthy even coined the term artificial intelligence in 1956 at the famous Dartmouth Conference.
Which brings us to Section 2, the AI winters, high hopes and broken promises. In the decades that followed, early AI relied heavily on strict logic rules, and it was genuinely incredible for certain things, like eventually defeating a world chess champion in 1997, but it failed entirely when it came to holding a simple, everyday human conversation.
Let's move to Quantry and see how this builds into a vicious cycle of immense frustration. In the 1960s, researchers were wildly, almost comically optimistic. They were confidently predicting that machines would be able to do any human work within just 20 years. Talk about overpromising, right? They completely underestimated the chaotic, unpredictable nature of the real world. So when the technology predictably failed to deliver on those massive promises, all that excitement turned to deep skepticism. We saw a brutal boom and bust cycle. The market would swell with hype, hitting $1 billion in 1985, only to entirely collapse just 2 years later in 1987. These devastating periods of shattered expectations became known as the AI winters.
The very first of these deep freezes was triggered right here. In 1974, a mathematician named Sir James Lighthill released a highly critical report. He bluntly concluded that all those previous years of AI discoveries had completely failed to produce the major impact researchers had so boldly promised. It was a harsh reality check. This report alone was the pin that burst the first hype bubble, prompting both the US and British governments to dramatically slash their funding for exploratory AI research. Making matters worse, around the exact same time, a book called Perceptrons was published, which heavily discredited early artificial neural networks. The field was starved of cash and practically abandoned by many of its brightest minds.
Section 3. The Big Data Breakthrough.
So, how on earth did we escape the winters? Well, slowly but surely, the AI field restored its tarnished reputation by doing something very smart. They stopped trying to build general human-like intelligence and started focusing on solving specific, narrow problems. And as they did this, the world around them began to change in ways that perfectly set the stage for a revolution.
Everything truly shifted in the year 2012. This is the vital pivot point, guys. A researcher named Geoffrey Hinton and his team demonstrated the staggering power of neural networks, which are computational models loosely inspired by the human brain, by training them to recognize and categorize digital images with a level of accuracy that absolutely blew the rest of the scientific community away. It proved once and for all that these neural networks weren't a dead end after all. But you might be wondering, why did neural networks suddenly work so perfectly in 2012 when they had failed so miserably decades prior? Simply put, it comes down to fuel. The early researchers had the right ideas, but they lacked the raw materials. Modern AI relies on three key pillars: incredibly fast computer chips, specifically GPUs, the massive, global expansion of the internet, and the endless ocean of big data that the internet generated. Suddenly, AI had the vast amounts of information and the sheer processing power it desperately needed to effectively learn complex patterns. This big data breakthrough is the direct reason you can ask Siri to check the weather or ask Alexa to play your favorite song today.
And that big data revolution rapidly accelerated us right into the generative era. Starting broadly around the launch of tools like ChatGPT, AI made a spectacular leap. It moved away from just organizing, sorting, or classifying existing data. Instead, it became capable of generation, creating totally new things. Literally overnight, anyone with a keyboard could type a simple text prompt and command an AI to write a comprehensive essay, generate stunning original artwork, or even code an entire website from scratch. It was a real game changer.
Section 4. Today's world, the era of AI agents. Now, what's really interesting about this slide is that the generative era of simple text prompts was really just a stepping stone. As we look at the reality of 2026, we are leaving those basic conversational tools behind entirely.
Back in the early 2020s, we relied on passive chatbots. They were incredible, for sure, but limited. You ask a question, it gives you an answer. Think about everyday household chores. A passive chatbot is kind of like texting a friend for advice. Hey, how do I get a coffee stain out of a rug? It gives you the steps, but you still have to do all the physical work yourself. Today, though, we have active AI agents. You don't just ask them questions, you give them a goal, and they autonomously take action. An active agent equipped with reasoning and memory is like having a digital coworker. You tell it, "I spilled coffee on the rug," and the active agent searches the web, finds the best reviewed carpet cleaning service in your zip code, checks your digital calendar for when you're actually home, and books the appointment for you. It's a massive, massive evolution from just talking to actually doing.
Let's look at another concrete example of this in action: planning travel. If you ask a passive chatbot to plan a trip, it'll basically just spit out a text-based itinerary. Have fun Googling all those flights yourself, right? But an active AI agent? It receives the overarching goal: plan a trip to Austin under $1,000. Step 2, it autonomously navigates the web, comparing flight prices in real time across multiple airlines. Step 3, it checks hotel availability, ensures the total cost stays under your budget, and actually handles the booking logistics using your saved credentials. It reasons through the obstacles, remembers your personal preferences, and executes the entire multi-step workflow on your behalf. So, the crucial point is this: we've traveled from abstract math and Alan Turing's imitation game, through the devastating winters of lost funding, all the way to systems that can autonomously manage our schedules and logistics. AI is no longer just a tool we talk to, it's a smart agent we collaborate with. As this technology transitions fully into a highly capable, active digital coworker, it opens up an entirely new question for you. Not, can a machine think, but rather, what tedious tasks are you ready to hand over? And how will you use this incredible technology to free up your own time? Think about that as you navigate this new era. Thanks for joining me on this explainer, and keep learning.